Hello everyone and welcome back to another video related to clustering. In this one, we are going to do an activity related to DBSCAN clustering. But before digging up into it, we are going to have a quick recap of what exactly it is. So let's get started. Density-based spatial clustering of applications with noise DBSCAN is an unsupervised clustering algorithm. The main point or idea behind DBSCAN is to find out whether a point belonging to a cluster is close to many points from that cluster or not. It separates clusters of high density, means having many data points, from clusters of low density, means having few data points. Now, the required parameters to form a cluster in DBSCAN clustering is the ellipson, which tells us the distance between one point to another. The minimum point means the minimum points in that area. The core point means the center point. Border points are the points that are on the border, and the outlier points are the points that do not have the either ellipson or the minimum points. The border point is on the border, as you can see. The core point is the green color. Now the ellipson is the distance, and the outlier is the point which is outside. Activity. Now we're going to play more with make underscore blobs. Make underscore blobs is a library where we can make our own data set with DBSCAN clustering. We are going to change the parameters or the requirements of the dataset creation by replacing the epsilon and the minimum points. So let's get into it. Now we are going to import the library as numpy.np sklearn.dataset import make blobs. Here is our library that we're going to use. And from sklearn.preprocessing import standard scalar and matplotlib.pyplot as plt. We are using all of these libraries for a reason, so let's get into it. Now we're going to determine the centroids, and this is where we are going to make our data set. So centers 1 is equal to brackets. We're going to give brackets, two brackets over here, and give whatever numbers we feel like giving. Of course, two numbers in one bracket, comma, then two other numbers in another bracket, and comma, and two last numbers in the last bracket. And we are going to pull the end bracket. As you can see, I've given 0.3 with 3, 1 with minus 1, 1.5 with 2. So let's see what's the output. Now we're going to create the data set. So xy is equal to make blobs and sample 400. Centers is equal to centers 1. So here we have a new variable centers, which is equal to centers 1 that we just gave right now. And cluster std is 0.5 while the random state is 0. Now what we're going to do, we are going to print x and y. And we're going to store standard scalar in a variable called scalar. So scalar is equal to standard scalar brackets and scalar dot fit transform x. So here we are putting all the standard scalar functions into x. Not the functions exactly, but we are training x with standard scalar. Now the figure or the fixed size is going to be 10 and 6. And plt.scatter is x colon y, x colon 1, c is equal to y, while the c map is going to be winter. These are all the necessary requirements for a graph. Now we're going to plt.show, and our scatter plot is ready. This is the winter theme, and as you can see, these are the clusters before DBSCAN is predicting it. Now what we're going to do, we are going to train the libraries, import the libraries, and train the data with DBSCAN. So let's get into it. Now from sklearn.cluster, we are going to import DBSCAN. And db is equal to dbscan, eps is equal to zero point 0.4, and minimum samples 20. As you can see, eps is equal, it means the distance. So the distance is going to be zero point 0.4 and the minimum sample is going to be 20. And db.fitx, now we're training x again. Yes, with DBSCAN clustering. Now what we're going to do, we are going to predict. So ypred is equal to db.fit underscore predict x. What we're going to do, we are predicting x. And now we're going to plot the resulted clusters formed. So plt.figure fixed size 10 by 6. This is the figure size. Now we're going to scatter. We're going to do the requirements, which is x colon 0, x colon 1, c is equal to y underscore pred, and c map is going to be summer. Means it's going to be summer theme. And the title is going to be clusters determined by DBSCAN. After we're done with that, this is our output. As you can see, some points, the dark green points are the outliers. The yellow point is one cluster, while the green point is another cluster. As you can see the difference. This is one cluster which there is no outliers and no prediction. And this is another. Of course, you're seeing the difference. Now we're going to move on to the next activity, which is going to be in the next video. So I'll see you then.